assignment. So the assignment that we're going over is on page 146. And I had you do 33 A, B, and C, and 34 A, B, and C. Okay, I'm going to start out with looking at 33B. No, I'm sorry, 33, I'm going to go easiest to most difficult. So that you guys can have encouragement, because like if you miss the first one, it's like, oh no. So we're going to do 33C, then 33B, and then 33A in that order, okay? So when we do that, we use our periodic table as our map. And today, we're going to show you different starting points on the map that you're going to use. But we won't get that until after we go through these answers. So lithium's element number 3. Okay? And element number 3, of course, has 3 electrons. So, when we fill levels, we normally fill up till we get to a certain point. We fill level 1, and how many electrons can fill level 1? 2. Then we fill level 2. How many can fill level 2? 8. And then we start filling level 3, but we're going to find out we're not going to fill all level 3 before we go to level 4. So it goes out and it starts out pretty easy. We fill level 1, boom, we're done. Fill level 2, we're done. Level 3, we start filling it, and then we find out we're going to go to level 4 before we finish filling level 3. And there's a reason for that, and we'll get to that. So we go in progression, and the road map starts at hydrogen and goes to helium. So at helium, we would be 1s2, and the first 2 electrons fill the s. And so on the road map, we're at helium. That's where we're at. 2 electrons, helium has 2. So then we've got one more to go. The first level's full. Doesn't take much to fill the first level. And then the next level starts to fill, and that's 2s1. So that would be lithium. Any questions on lithium? So the next one we're going to go to, that's letter B, would be sodium. So then I'll put sodium here, Na. And then sodium is element number 11. So we start out 1s2. We fill the first level. We fill the second level. Okay? And if you, let's have your book out. If you're not, turn to page 146. Let's have you turn to page 146 because that's what we're basing our answers on. If you look on page 147, you have a periodic table that tells you where every sublevel's at. Okay, they have, this would be the S's, this is the D's, these are the P's, and these are the F's. Okay, we don't get into the F's until element 50 and the upper 50s. Okay, so they're a little bit more precise because they tell you what level that S would be and what level that D would be, and the same with P's. So as we're going across, the first one we have would be lithium, and we're not done with sodium yet. So if we're doing sodium, we go through the first 2, and this ends in 1s2 there. Then we go to our next one, and we go to beryllium, and and beryllium is here, and that would be the 2s2. So beryllium, this one is 2s2. Okay? But then we go through all of these next. There are 6 of them. And then we're there, and that's 2p6, right? So right now, if I'm using my periodic table, I can use it in progression 1 through my number, which is 1 through 11. This would be 10 electrons there. So we have 10 electrons right there. So now all we have to do is go one more, okay, and there's sodium. The sodium's in the S's, right? So then it should be 3s1. Okay? So, you guys notice something about lithium and sodium? They're ending? They're S, and they're also 1. So, I bet you could tell me what potassium is in, right? S1. What S1 would it be? 4s1. Okay? So, you could probably tell me what cesium would be. I skipped one. I tricked you. Cesium. What's cesium? 6s1. How are you knowing the level S's? You just count down, right? Hydrogen's 1, lithium's 2, sodium's 3, potassium's 4, rubidium's 5, cesium's 6, francium's 7. So we already know those just remember that they all end in S1 and the next row all end in S2. So you kind of have an idea there's a pattern here. A lot of chemistry is patterns. If you pick the pattern out and get the pattern, and sometimes the patterns kind of, like when we get into nickel, it kind of changes, but that's okay if we know the reason why. So let's say that we're going to do nickel. And nickel is element 28. So we got 28 electrons to account for, and we do this by electron configuration. Now, getting back to lithium and sodium, something that I'll bring up from time to time is that, for the most part, we're going to be concerned with the outer layer. So can you tell me, lithium, how many electrons are in the outer layer of lithium? How many electrons are located in the outer layer of lithium? How many? What's the outer layer? Which one? Is 1 the outer layer? Is 2 the outer layer? Yeah. So how many electrons? 1. How many in the outer layer of sodium? 1. Okay, we did this. Remember we did that periodic table where we tried to put it together? And what did we know about that group 1? They all reacted alike. Why? Because the electrons in the outer layer causes it to react the same way with the same number of electrons. So that's why we're doing this. For the most part, we don't concern ourselves with the inner layer. Okay, we'll talk about it. The outer layer is more important than the inner layer. So when we do electron configuration, it tells us how many electrons are in the outer layer. So nickel, we go 1s2. We're at what element? What is that element? Helium. 2s2. What element are we at? Beryllium. Then 2p6, where are we at? Neon. Okay, now we're in the third row across. And that'd be a 3s2, where are we at? Magnesium. Okay, so I'm using my road map until I need to get to nickel. So right now on my road map, I'm at magnesium. And magnesium is located right here. So now I've got to go through all of these. And I need to get there. So what comes next? The 2 P's have already been used up. I'm in my P's, so it'd be 3p6. Now here's the problem where you guys have probably missed this. Is what comes after this one? What sublevel comes after this one? The S's. And some of you would have wrote D's down. Because you're thinking each layer has to fill level 1, level 1 is S's, level 2 S's, P's, level 3 has to be S, P's, and D's. So some of you would have put 3D down. But you have to go through this S's to get to the D's, and I'll explain the reason why. And I won't explain this probably many more times than this. I might bring it up. But here's the deal. We've got this energy level, and Aufbau's principle says that electrons must fill energy levels, the lowest ones first, before they can fill higher level electrons. So what happens, it goes 1s, and then energy, this would be going up in energy. So it goes 1s, and then the next one's 2s, and then 2p I can put over here. Just, it's a little bit more higher level. And then we go 3s, and then we go 3p there. So it goes in that order. And then I'm going to put 3d up here, and then I'm going to put 4s here, energy-wise. So it goes in progression, 1s, 2s, then 2p, then 3s, then 3p. Which one will the electron go? Lowest energy, here. It won't go to the D. And that's just a fact, that a D, 3D is more energy than a 4s. But your periodic table helps kind of show that too, is because right now you're going to be here, so then the next one would be 4s2. Would not be 3D, because we're right here, and these are the S's, and if it's right below this one, it's going to end in S2. So then we go across the next row, 1, 2, 3, 4, 5, 6, 7, 8. So then that would be the D's, right? But what level of D's? 3. Very good. Because we haven't used the D's in the third level yet, there becomes what looks like a change in the pattern there. Once we get to the D's, there. So how many electrons are in the outer layer of nickel? Nope. I got to put 8 here to be right. So how many electrons in the outer layer of nickel? So which one's the outer layer? 1, 2, 3, or 4? 4. Here's a 4. How many electrons? 2. There's 2 in the outer layer. It has. So most of the time we're going to talk about only outer layer electrons because they're the ones involved in bonding taking place. Questions on that? This one's a tough one. I doubt if you probably got it. I noticed some of the papers did. That's good. If you got it, and this is hard to forget. Once you get this down, it's like, well, I'm going to forget by tomorrow. Possibly. Okay? But I think if you understand the progression of the periodic table and where you're at, what level, S's, D's, or P's, or F's when we get to them, you kind of know where you're at on the map. And you always go from the lowest number to the wherever you're trying to get on the map. All right? So I'm going to go ahead and just name off these 2 answers, and then I'll write the third one up here so that you can look at it, because this is the one that's probably most commonly missed. So 34A, we're looking at nitrogen. So nitrogen would be 1s2, 2s2, 2p3. Okay? Then chlorine. Chlorine would be 1s2, 2s2, 2p6, 3s2, 3p5. And then strontium, I'll go ahead and write strontium up here so that we can have it. So strontium is 38 electrons. And so it'll be 1s2, we're at helium. 2s2, we're at beryllium. 2p6, we're at neon. 3s2, magnesium. 3p6, argon. 4s2, we're at calcium. 3d10, we're at the end of that, we're at zinc, if you're following along. So we'd be right here is where we'd be. Now we got to go through all these p's, and that would be 6. So now we're at krypton at 4p6. There's a tendency for students to like to write 3p6, but we've already got those filled, so you can't refill them. And then we're over here in the 5th row. 1, 2, 3, 4, 5. So that would be the 5 S's. And there would be 2 of them. So that would be the answer for strontium. Make sense? Now, we do not want to go through that every time we do elements, especially when we get farther down the periodic table. Lithium's fine. We can do it that way. We can start with hydrogen. Sodium's fine. We can do that way. It's not a stretch. When we get down to nickel and strontium, there's an easier way to do those. And the easier way to do them is to not start with this element every time, because it becomes long and laborious. But it's good to know the shorthand for a little bit longer one, or this one, all the way from hydrogen. But at some point, we need to progress and realize we can have different starting points and come up with electron configurations. Because really, we're only concerned with the outer layer for the most part after a certain portion of time. So let's say if I did nickel. Let's say I do nickel and I want to shorten it up. I don't know why I did that. But let's say that I do nickel and I want to shorten it up. I'm going to erase something here so I can have it. I better not. I'm going to erase this one. So let's shorten up nickel. And let me show you how you'd shorten it up. You just have to know where your starting point would be, where you're going to go. And our starting point is always going to be starting with this row here. What do we call these? Noble gases. So we're going to start with the noble gases. A lot of times it's called the noble gas configuration or abbreviated configuration. I call it the shorthand because it shortens up how we do it. So here's nickel. So what I want you to do is I want you to find the noble gas that's in the row above nickel and tell me which one it is. In the horizontal row above nickel, it's argon. So I'm going to put argon, and I'm going to say, you know what? I'm starting at argon. I'm not starting at hydrogen. I'm going to start at argon, and from that point on, I'm going to show where the electrons are at. So what's the element right after argon? Okay, so potassium. So what I'm going to do is I'm going to say, do I know what layer electrons are filling when potassium is being filled? So 4s. Okay, do I fill both S's for nickel? Yeah. I do, because nickel's in that row further on. So I'm going to go 4s2. Okay, then I know what layer sublevel I'm at, right? What comes next? The D's. So I'm going to write a D here, but I need to know what level the D's are being filled. Some students like to put 4 D's, but we can't put 4 D's because when we go up in progression, it goes 1s, 2s, and then what's next is 4s, and then the 3 D's. So you just have to remember that the D's are always one level earlier because of energy. So we'll go 3D, and then what would it be? 8. Now, this is what I expect you to be able to do after going through some discussion today. Would you rather do this, or would you rather do this? You'd rather, I think for the most part, you really get it, and that would be 9 out of 10 students get it. There's always students that, for some reason, they can't figure out where they're going to start. So let's do strontium. Where do we start for strontium? What noble gas do we need to pick for strontium? Which one? Krypton. So I'm going to go Kr, and I'm going to start from Kr, and so I'm going to go from Kr, and so what would be my starting point? 5s2. And then I'm done, right? Isn't that a whole lot easier, right? It's a whole lot. And why is that important? Because we're only interested, for the most part, in the outer layer. So when you look at this, go through all of this progression, you find out, oh, wait a second, there's only 2 electrons in the outer layer. It's the 5th layer. I'm only interested in those 2 electrons. Okay? So, we're going to have you practice a couple shorthands. And then give you an assignment, and you should be able to get it done today. And not have to worry about homework. You should be able to get it done. So I'm going to go ahead and give you 2 and see if you can figure out what they're going to be when you're done. So the first one, excuse me, I'm going to give you is element 10, SN. So I'm going to give you SN, and I'm also going to give you element CS, cesium. So do those 2, and then we'll check to see if you got them figured out or not. That would be element KR. So we put KR, we count down the row, and we go 1, 2, 3, 4, 5. So it'd be 5 would be the 5th row, and we go 5S2. Then the D's are 1 behind, 4D10. And then element SN's 2 elements into the P's. So now we're in the 10 are already filled up, so we start filling the P's, and it has to be the 5 P's. It's not the 4 P's. Some of you have a tendency to write a 4 P. You have to understand that the row above was the 4 P's. So that'd be 5P2. So there's a tendency to follow your numbers. So if I put a 4D, the next has to be a 4P. Well, if we did the longhand, the 4 P's have already been filled. So that'd be 5P2. Any questions of that? Then the next one's really easy, because all we have to do is put xenon in brackets, and then we go down the row, and it's 6th row, so it'd be 6S1. And we're done. 6S1, we're done. We don't have to go any farther. It only has 1 electron in the outer layer. So we're going to give you some abbreviated ones to do, and we'll check them out tomorrow. Okay, completion assignment. Would like you to do 35. Oh, we need to go through answer for 37 and 38. We didn't do that, right?
Yeah.
So real easy. 37 is lithium for A, and then for B, the element is titanium. And then for 38, A would be oxygen, and then C would be argon. Okay? So what I want you to do for tomorrow, abbreviated, would be 35 BCD.
What page?
It's same page, 146 is the last assignment. It'll be BCD. And then for number 36, it's ACD. So 35 BCD, 36 ACD. And that's all you have to do for tomorrow. Okay?